Okay, so I want to do a couple more related rates. I like to do them just a couple at a time so none of the videos get really long. So this one is going to be looking at the speed of an airplane. And again, my beautiful artistic ability is going to be on display here. So I have an airplane that's flying at a constant altitude of 6 miles. So I'm just going to put 6 miles here. As it's flying overhead, there is a radar station. I'm not even going to try to draw it. We'll just put R for radar station. And here's my airplane. Again, I'm not even going to try to draw an airplane. Believe me, I've done it in the past and it's not pretty. So I have an airplane flying and it's flying at a consistent altitude of 6 miles. The distance between the radar station, which I'm calling R, and the plane is decreasing. So this distance, since it's a hypotenuse, we'll say it's C. This distance is decreasing. So that means that it's a rate that is decreasing at a rate of negative 400 miles per hour. And we want to figure out when the distance is 10 miles, so when it's 10 miles from the plane to the radar station, what's the speed of the plane? So we also need to label this side. So I like to call anything horizontal X. So when you're asked about speed or something changing with respect to speed, that is always going to be how your horizontal distance is changing. So we're going to refer to that as dx over dt. That's what you're looking for. You're looking to see how this distance is changing, and that's going to be your speed. So I have another kind of ladder problem. It's a Pythagorean-based problem. I have my two sides that are changing are the x side and the c side. Now this is not changing, so I'm going to leave that as 6. So I can write a formula that connects them all and say that x squared plus 6 squared equals c squared. The reason I didn't put a variable where the 6 is because that's not changing. It's constantly flying at altitude of 6 miles. So I'm going to take the derivative, which is 2x dx dt. The derivative of 6 squared is just 0, and that's going to equal 2c dc dt. The 2's will cancel if you want to do that. So let's plug in what we know. We know my c value is 10. We also know dc dt is negative 400. My x value is going to come from the Pythagorean theorem. So if I know that my c is 10 and my other leg is 6, then my x is going to be the square root of 10 squared minus 6 squared, which ends up being the square root of 64, which ends up being 8. So I get an 8. And I am looking for dx dt because I'm looking for the speed, which is going to be the change in the horizontal length. I'm going to divide both sides by 8. And I'm going to grab a calculator just to make life easier. So 400 times 10 divided by 8, I get 500. Now the negative, when we talk about speed, and this is kind of a physics conversation, speed doesn't have a sign. So you do not have to put the negative. You will just put 500. And we are talking speed, so we are in miles per hour. So that is how fast the plane is moving. So that shows you another example of a Pythagorean-based question, but this time that speed is that change in that horizontal distance. The one other one I want to do in this video is I want to show you one of the ones they do in Delta Math. Delta Math kind of breaks it down into what shape. Is it a triangle shape like the one we just did? They also do rectangle ones. So let me show you a rectangle one. So I'm going to draw a rectangle. That is the extent of my art ability. I'm going to draw a rectangle. Has a length of 12 inches. It has a width of 10 inches. But those sides are changing. We have my length is increasing, so I'm going to call this dl dt is increasing at a rate of 10 inches per second, while my width is shrinking, so that's going to be a negative derivative at a rate of 2 inches per second. So I have, again, L for length, W for width. You can use X and Y if you prefer. And the goal is to figure out how is the area changing. So that's all my given information. I like these because I can draw a rectangle. So I have how the length is changing. I have how the width is changing. I have the certain particular time that these things are happening, like what the length is and what the width is. And then finally, I want to know how the area is changing. So we need to start with a formula that relates all the different quantities. So my formula is pretty basic. It's just area equals length times width because it's the area of a rectangle. When I take the derivative of that, so the derivative would be dA dt, notice that I have to do a product rule here because I have a length times a width. So I'm going to do first times the derivative of the second plus second times the derivative of the first. To this point, we really haven't got into anything that had a product rule, but it can happen when you have formulas that have quantities being multiplied. You're going to plug in everything that you know. So you know the current length is 12, and the current width is changing at a rate of -2. And then you know the current width is 10, and the length is increasing, so it's positive 10. So you're going to get -24 plus 100, which is 76. And you don't actually have to put a unit in Delta Math. It'll actually put the unit for you. But this is an area, so this would be inches squared per second. So at that moment, the area is increasing at a rate of 76 square inches per second. So that's how the Delta Math works with rectangles. Again, there are triangle ones, there are a lot of Pythagorean ones, there are circular-based ones, but I wanted you to see an example of this.